I think that biomedical research is worth exploring in the sense that it's the mechanism through which we're asking questions that are going to help people. My name is Joseph Foster. I've been working here at the Hussman Institute for Human Genomics at the Miller School of Medicine at the University of Miami under the tutelage of Dr. Mustafa Tikin for about 2.5 years now, primarily focusing on the research of genetics of deafness. The main instrument of investigation that we've been using is whole exome sequencing in the sense that we're looking for novel genes associated with genetics of deafness. Our ultimate goal is to be able to discover novel deafness genes. We're in the hunt for the remaining deafness genes that are yet to be discovered. My role in that right now, as it is basically running experiments that are confirming potential variations that may lead us to novel deafness genes. I was born in Denver, Colorado, and my father at the time and still is an electrical engineer, so science has been around me my entire life. I'll do what I just did. So my interest in biomedical research started when I was a little bit younger. One of my close family members was born with cystic fibrosis, and that kind of really kick-started my interest in understanding a little bit more thoroughly about genetics and how it's impacting this really important person in my life. When I reached high school and I took my first introductory course to biology as a freshman, I just remember being very intrigued by the process of DNA replication and some of the basic concepts that were introduced at that course. I've played saxophone and I've always been involved with music really since I was very young, probably 8 or 9 years old. And I guess it was a moment of serendipity when I came here, and it was genetics of deafness, and I was able to understand the ear, which is obviously pivotal to being able to play music. What I find interesting about working in the lab is the dynamic nature of what's actually going on and what's being investigated. Mutation in your DNA can result in a faulty part of your body. And so in our case, we're looking at mutations in genetic and deafness genes that result in congenital deafness. So the patients are born without the ability to hear. I think what's really been rewarding for me in this whole process is really just the idea that once we find something new or something really neat, we're able to give that to a patient. Okay. Double click on that Cuba data. The neat thing about biomedical research, and specifically about genetics research, is you need to have the ability to collaborate with people who are working in different fields. You're not operating in a vacuum. You're a person that's part of a team. I think success for me is very much wrapped up in how what I've done is benefiting other people.